When a semi-permeable membrane is placed between a pure solvent and solution, it is found that more solvent molecules enter the solution side. The flow of solvent from the pure solvent to the solution side makes the volume of the solution increase. The occurrence of the natural flow of solvent molecules through a semi-permeable membrane from a pure solvent to a solution is referred to as osmosis.
Osmotic pressure. Osmosis can be stopped if some external pressure like hydrostatic pressure is applied from the solution side. This external pressure tightens the solvent molecules closer together, raising their escaping tendency from the phase. If enough pressure is used, the escaping tendency of solvent molecules from the solution will be bound to the molecules in the pure solvent, and osmosis will be eventually stopped. The pressure required to prevent osmosis and achieve osmotic equilibrium is known as osmotic pressure.
Just like the previous lessons, osmotic pressure is a colligative property wherein it depends on the number of solute particles present and not on the identity or the nature of the solute. The equation showing the direct proportionality of the osmotic pressure of a solution to its concentration is quite similar to the ideal gas law, as shown in equation 6.4.1. However, in the equation 6.4.2, it is convenient to arrange terms to yield. This form of equation has been derived by realizing that the quotient N over V gives the concentration of the solute in units of molarity, where M is the molarity of the solution, R is the universal gas constant, and T is the absolute temperature in Kelvin.
Tonicity. Tonicity is defined as the measure of the relative concentration of solution dissolved in solution on the either side of some permeable membrane. In other words, it is the measure of the osmotic pressure gradient. Three terms, isonic, hypotonic, and hypertonic, are used to determine the path or extent to which solvent moves by osmosis.
Now, what is isotonic solution? This is a type of solution where the two solutions have equal osmotic pressure at any given temperature. When a semi-permeable membrane is placed between two solutions, no osmosis will occur.
Hypotonic solution is where the osmotic pressure of the dissolved solute is lower than the osmotic pressure solution inside the cell. As a result, the solution inside the cell will take in water or solvent, making the cell swell and eventually burst.
Now, when the osmotic pressure of the dissolved solutes is higher than the osmotic pressure inside the cells, the solution is defined as hypertonic or hypertonic solution. The solvent or water inside the cells will force their way out to equalize the osmotic pressure, causing the cells to shrink.
Remember, isotonic iso means the same, no net movement of water. Hypotonic hypo means less than a net movement of water into the cell. Hypertonic hyper means greater than a net movement of water out the cell.
Now let's try solving the osmotic pressure. Example 1. Easy. Find the osmotic pressure of a 2.5 molarity solution of glucose at 25 degrees Celsius. First, you have to identify the given in the solution. The molarity is given, which is 2.5, and then the temperature is given, which is 25 degrees Celsius. And we have to convert the Celsius into Kelvin by adding 273.15. It becomes 298.15 Kelvin. And then we use the formula for osmotic pressure, which is molarity times gas constant times temperature. Then we have to substitute the given. The molarity 2.5 or molarity or mole over liter. And then the gas constant, which is 0.08206 liter times atmospheric temperature. and mol over mol times Kelvin, and then multiplied by the Kelvin, which is 298.15. Crush out the mol and the liter, and then the Kelvin. If we multiply it, it becomes 61.17 atmospheric temperature. This is our osmotic pressure.
It's easy. Find the osmotic pressure of a 1.5 molarity solution of glucose at 30 Celsius. Step 1. Identify the given. Given nato molarity, kung ita nato 1.5 mol over L. Nato temperature 30 Celsius plus 273.15. Ato siyang absolute zero equals 303.15 Kelvin. Itong sa ikaw nato 30 plus 273.15 ra 303.15. So sayon ang R nato universal gas constant 0.08206 L times ATM over mol times K Kelvin. Step 2, identify what is asked in the problem. Itong problem is to find the osmotic pressure of a solution. Step 3, write the working equation atong formula dara. Osmotic pressure equals M molarity R atong universal gas constant, then T atong temperature. And step 4, substitute the values dara. Itong M calculator is 1.5. Then atong kuan nato ang R ra 0.08206. Atong temperature dahil nato ito pangitaon tara 303.15. Oops, ato ang parenthesis. Okay, so ang answer nato is 37.3147335. Atong kwaon is the nearest hundreds of decimal. So atong answer is 37.31 ATM. Man ATM ato siya atong gi cancel out ang mga kaparehas. Ang labihan is ATM. And that's it.
We have our second example in the average. The problem is to determine the osmotic pressure for a solution containing 10 grams of non-electrolyte solute dissolved in 20 liters of solution at 25 degrees Celsius. The molecular weight of the non-electrolyte is 150 grams per mole. For the second example, let us identify the given. The given is M solute equals to 10 grams, and the volume of the solution is equal to 20 liters, and the temperature is 25 degrees Celsius. So we have to convert it to Kelvin by adding 273.15, and it becomes 298.15 Kelvin. Now we have to convert the grams into mole. So we do that by 10 grams multiplied by 1 mole over 150 grams, because this is the molecular weight of the non-electrolyte, which is 150 grams per mole. Then as we multiply it, it becomes 0.07 mole. Then we have to solve for the molarity of the solution, which is mole of the solute over the liter of solution. So 0.07 mole over 20 liters is equal to 3.5 times 10 to the power of negative 3 mole over liter or molarity. Now we can substitute it in the formula. 3.5 times 10 to the power of negative 3 mole over liter multiplied by the gas constant. And the temperature, which is 298.15 Kelvin. Scratch out the mole, the liter, and the Kelvin, and it becomes 0.09 atmospheric pressure, or our osmotic pressure is 0.09.
Try it average. Determine the osmotic pressure for a solution containing 20.0 grams of non-electrolyte solute dissolved in 30.00 L of solution at 30.0 Celsius. The molecular weight of the non-electrolyte solute is 120 G over mol. Step 1, identify the given. Pangitan na itong M solute, which is 20 grams, dara, 20 grams. B solution, 30 L, dara, 30 L. Nga itong temperature, 30 Celsius, dara, 30 Celsius, na plus 273.15. Ay plus na po na siyang duha, mo siya 315 Kelvin. Step 2, identify what is asked in the problem. Itong pangitan na itong osmotic pressure for a solution. So, write your working equation, the rate of formula. Osmotic pressure equals M, molarity R, itong rato, itong universal gas constant nga T, atong temperature. Step 4, substitute the value. First, solve for the concentration of solution in molarity. Para makuha na itong molarity, so 20 grams, itong 20 grams M solute over 120 grams per mole. So, asa gikan 120 grams per mole, dara. 120 grams per mole. So, atos lang kuha na to, calculate na to. So, 20, atong divide 120, answer around 1.667 and so on. So, na siya ang kuha na to. So, para makuha na to ang kuha na to, magkuha na po taog, divide na po na siya sa 30 out of B solution. So, atong answer ganiha, o itong 30, baba na siya, baba, 30, 30L, mo siya 555 and so on, mol L. So, atong kuha na po na to siya. Atong na po siyang, pag makuha na to ang molarity na to. So, molarity nga ito, so substitute the value to the equation. So, itong ganiha, itong answer ganiha. Nga ito ang atong R na to, dara 0.08, 0.08206. Na po, ato ang temperature na to. Temperature na to is 303.15. 303.15 equals 0.138202767. Atong paano naman na to is hundreds to the nearest decimal number na to. So, 1.13. So, dira itong answer, 0.13 ATM. 0.13 ATM. Mga na ATM, atong gi-crash out, atong mga parehas. So, nabilin is atm. So that's it.
For the last example, a mass which is 0.558 grams of a compound X is added to make 325 milliliters of the solution, having an osmotic pressure of 675 millimeters of mercury at 25 degrees Celsius. Find the molar mass of the compound X. Let's identify the given. The mass of the compound X is 0.558 grams. The volume of the solution is 325 milliliters. The osmotic pressure is 675 millimeters of mercury, and the temperature is 25 degrees Celsius. Let's convert the terms that we can convert. First, we have to convert the milliliter into liters. 325 millimeters is multiplied to 1 liter over 1000 millimeters. It's equal to 0.325 liters. And then from millimeters of mercury, I have to convert it to atmospheric pressure, which is 1 atm over 760 millimeters of mercury. And this becomes 0.888 atmospheric pressure. Then we have to substitute the values. Then we have to convert the 25 degrees Celsius into Kelvin by adding 273.15, which becomes 298.15 Kelvin. Then we are looking for the molarity in the solution. So we'll change the formula of osmotic pressure into this. Molarity is equal to osmotic pressure over gas constant times temperature. So you have to substitute the values. 0.888 as atmospheric pressure over the gas constant multiplied by the temperature. Cash out some terms. Becomes 0.0363 mole over liters for molarity, or 0.04 molarity. Then we have to determine the amount of the solute in moles using the concentration and volume of the solution. To do this, have to multiply our molarity by the volume of the solution. It's equal to 0.013 mole. Lastly, we have to determine the molar mass using the mass provided and the calculated moles. The molar mass is equal to the mass of the solute, which is 0.558 grams, divided by the number of moles, which is 0.013 moles. It becomes 42.92 grams per mole. Therefore, the molar mass of the compound X is 42.92 grams per mole.
Try it. Difficult. A mass of 0.06 grams of a compound X is added to make 300 ml of a solution having osmotic pressure of 500 mmHg at 30 Celsius. Find the molar mass of the compound X. So, step 1, identify the given. Atong ngita nato ang M, which is mass nato, equals to 0.06 grams dira. Sa atong V solution, 300 ml dira. Ato ang osmotic pressure. Dira atong osmotic pressure. Ngita nato T, temperature, 30 Celsius. Plus 273.15. Ang answer is 203.15 Kelvin. Atong R na to 0.08206. L times ATM over mole times Kelvin. Step 2, identify what is S in the problem. Kung na to kay problem na to in mole, find the molar mass of the compound X. Step 3, write the equation dito itong formula. M equals osmotic pressure over R nga T, temperature. Step 4, substitute the value of the and solve the problem. First, convert the pressure from mHg to atm. So, itong ato osmotic pressure, convert nato siya into atm, 500. Diba, nato 500. I-convert nito siya sa 1. Nga sa baba is 760. 760. Ang magawas na kay 0.67894736 and bagay siya 80 naman siya ATM. Secondly, substitute the values. Magkana tayo sa itong formula. So, ito ang osmotic pressure to ganiha. Ang ganiha na ito. Ang na-answer sa osmotic pressure. Then, atong R nga, 0.0 8206. Yes, ato ang temperature. Atong temperature nato 303.15. 303.15. So, ang answer nato is 0.0264 and so on. Nara. Nakuha na nato to ang molarity nato. So, determine the amount of the solute in moles using the concentration volume solution. So, ako na to. Ito siya, in mole na to siya. So, itong answer ganiha. Ang answer ganiha. Then, ikaw na sa 0.3 L. 0.03 L. Ano siya? Equals, then mag 7.937 so on. Economics na kuha na to ang mole. So, lastly, determine the molar mass using the mass provided and the calculate the mole. So, atong pangita atong mass ganiha. So, it is 0.06 0.06 grams. O katong answer na to ganiha. Para itong mole na to ganiha. Tara. Oops. Tara, ang magawas is 7.56245256 At mukha naman tag hundreds sa decimal, ikan sa decimal. So, itong answer is 7.56. Tara. So, itong kuha na to is 7.66 grams per mole. And that's it.